Most teams assume AI agents will standardize their Power BI or Fabric models. They won't. They'll produce something that looks consistent, compiles, and even performs, while the meaning quietly changes underneath you. That's architectural drift. The system still answers questions, but it no longer answers them the same way, for the same reasons, across teams and time. In the next few minutes, this will get defined in Fabric terms, then tied to the exact places drift starts: measures, relationships, transformations, and report semantics. Because speed without intent becomes entropy. Define architectural drift in Power BI Fabric terms. Architectural drift in Power BI and Fabric is simple. The semantic meaning of your data changes without explicit intent, without review, and without an accountable owner signing off. Not the model broke, not refresh failed, not a report error popped up. Drift is worse. Drift keeps working. A measure returns a number. A visual renders, a stakeholder exports to Excel and forwards it to finance. Everyone nods. The only problem is that the number is now answering a slightly different question than the one you think you asked. That distinction matters because Power BI's semantic model is not a dashboard toy. It is an authorization and meaning engine. It encodes how the organization defines revenue, headcount, churn, backlog, margin. Whatever your executives insist is one number. And drift happens when that meaning changes via small local edits that look harmless in isolation. So what does that look like in real model terms? Start with measures. A measure is a contract. It defines a business concept under filter context. When that definition changes, even by optimization, even by refactoring, even by helpful AI cleanup, you've changed the contract. If nobody approved it, that's drift. Then relationships. Relationships decide filter propagation, which decides what counts as included. You can keep the same measure text and still get different results if an agent adds a relationship, flips cross-filter direction, or creates a many-to-many shortcut. The model still works, it's just now answering a different question. Then Power Query and transformations. A Power Query step that trims white space, replaces nulls, merges two sources, or changes a data type looks like plumbing. But it can change cardinality, keys, and join behavior. That's not plumbing, that's meaning. Drift shows up when the transform changes, and nobody records why the business definition changed with it. Then calculation groups. They're powerful because they rewrite measure evaluation at query time. They're also dangerous because a small change can apply everywhere. When an agent adjusts time intelligence logic, YTD, MTD, fiscal calendars, it can globally redefine what this year even means across the tenant. Then report semantics. In PBIR or PBIP, the report isn't a single file anymore. It's a graph of definitions, page JSON, visual JSON, themes, interactions, filters, bookmarks. So drift can happen purely at the presentation layer, the same model, the same measures, but a filter moved from page level to visual level, an interaction disabled, a hidden slicer left behind. Users see a stable report. They're wrong. Now separate drift from defects because governance failures come from confusing the two. Defects are loud. Something breaks. You get errors. Incidents happen. People respond. Drift is quiet. It passes validation. It ships. It becomes truth through repetition. That's why drift is the default outcome when you delegate modeling to agents without designing the controls first. Agents are pattern engines. They produce plausible structures. They don't carry your organization's semantic intent unless you force it into the workflow. And Fabric makes this easier to trigger at scale. Fabric encourages reuse. Shared lakehouses, shared warehouses, shared semantic models, shared notebooks, shared APIs, and multiple teams shipping at the same time. That's great for velocity, and it's also perfect conditions for drift, because now the model stops being a product with an owner and a roadmap and becomes an artifact that exists because someone needed a report by Friday. Agents amplify that behavior. They make it cheap to create just one more measure, just one more relationship, just one more version of a KPI. Over time, those just one more choices accumulate, and the organization ends up with a semantic layer that is no longer deterministic. It's probabilistic. Your answer depends on which workspace, which model, which measure variant, and which agent last touched the definition. Next, the foundational misunderstanding that makes this inevitable. Agents don't understand your business. They approximate it. The foundational misunderstanding. Agents don't understand your business. Agents don't understand your business. They understand your prompts, your metadata, and whatever patterns they've seen that look like your situation. That's not the same thing. And in semantic modeling, that distinction matters more than anywhere else because close enough becomes a KPI. Here's the uncomfortable truth. Most people evaluate an agent's output like they evaluate autocomplete. Does it look right? Does it run? Did the chart appear? If yes, they ship it. But a semantic model isn't text. It's an executable definition of meaning. If the definition is slightly wrong, the organization doesn't get a slightly wrong report. It gets two competing realities that both look official. The system did not fail. Your assumptions did. An LLM is a pattern engine. It predicts the most plausible next step given the inputs. Sometimes that looks like reasoning. It isn't. It's approximation under uncertainty. And BI is a domain where uncertainty has to be eliminated, not embraced. So when an agent generates a measure, it is not deriving the correct business logic. It is selecting a plausible formula shape, SUMX patterns, calculate patterns, time intelligence patterns, common KPI templates. If your organization's definition matches those shapes, great. If it doesn't, the agent will still produce an answer. It will just be wrong in the specific way that sounds confident. Now add non-determinism. Even if you prompt the same agent the same way, you are not guaranteed the same modeling choices. Model temperature, context window changes, updated system prompts, different tool availability, and subtle differences in retrieved context all push the agent toward different outputs. That's fine for brainstorming. Governance hates it. Because governance is built on repeatability. The same inputs produce the same outcomes, and changes are intentional. Agentic modeling turns that deterministic security model into a probabilistic one, where what happened depends on which run you're looking at. Then there's the close enough trap. An agent will happily map net sales to a column called sales amount, or infer active customers as distinct count, customer key, with a filter on the last 30 days, because that's a common pattern. The problem is that your enterprise definition might exclude returns, include only invoiced transactions, require posted status, align to fiscal periods, and treat churned customers differently across product lines. If the agent doesn't have those constraints, it cannot invent them correctly. So it invents something else, a plausible business definition. That definition then gets reused, copied, and referenced. And because it compiles, it becomes truth by repetition. This is what hallucination looks like in BI. Not making up a number out of thin air, making up the definition that produces the number. The weird part is that hallucinated definitions don't throw errors. They can produce perfectly consistent results. They can even match expectations for a while, until someone runs the same question in a different model with a slightly different definition, and the executive meeting turns into a debate about which reality is the real one. And Fabric increases the blast radius. With shared assets and APIs, an agent doesn't just help one developer in one PBX. It can propagate patterns across workspaces. It can mass edit measures. It can replicate modeling templates. The same approximation becomes standardized drift. Now, to be precise, this is not an argument to ban agents. Agents can be useful, especially when you treat them as accelerators for repetitive work and documentation. Even SQL BI has been explicit that effective AI use depends on building blocks like context, tools, and environment, not just prompts. That's the point. Without scaffolding, agents will fill the gaps with whatever looks plausible. So the foundational misunderstanding is simple. You think you're delegating understanding. You are delegating decision-making under ambiguity. And unless you constrain that ambiguity, the agent will resolve it for you, quietly, repeatedly, at scale. Next, that misunderstanding becomes concrete in the most common drift vector, measure generation, where semantic forks multiply faster than teams notice. Where drift starts, measure generation as a semantic fork bomb. Measures are where drift becomes scalable because measures are easy to create, easy to copy, and hard to police once they spread. The agent doesn't need to redesign your schema to change reality. It just needs to generate one helpful KPI, and then another and another. That's why measure generation is the semantic fork bomb of Power BI and Fabric. It multiplies definitions faster than your organization can notice, let alone agree. The first failure mode is duplicate definitions. You ask for net sales and the agent produces a measure. Another team asks for net sales in a different workspace and the agent produces a slightly different measure. Same display name, same folder, same tooltip description that looks professional. Different logic. One version subtracts returns. Another version subtracts discounts. A third version filters out internal customers. A fourth version uses a different date column. None of these are obviously wrong. They're just different contracts wearing the same label. And because Fabric makes it trivial to reuse artifacts, those variants don't stay local. A report references one. A data agent references another. Someone exports a table and pastes it into a deck and calls it the number. Now the organization has multiple canonical truths and nobody can prove which one was intended. The second failure mode is filter context traps. DAX is not hard because it is complicated. DAX is hard because it is contextual. A measure isn't a formula. It's a formula evaluated inside a shape of filters you often don't see. Agents will produce time intelligence quickly. That's their favorite trick. YTD, MTD, rolling 13 months, prior year comparisons. The problem is that every one of those patterns assumes something about your calendar table, your relationships, your fiscal logic, and which date column is the date. If your model has a single marked date table, single direction relationships, and consistent date usage, you can survive that. Most models don't. So the agent guesses, it picks date, or it picks the fact table date, or it mixes them across measures. The measures still return values, and they'll even look correct in a single visual. But move the slicer, change the grain, Add a second date attribute and the measure's meaning shifts. That's drift through implied assumptions. The third failure mode is naming drift. Humans already struggle with naming. Agents do it faster, not better. You end up with measures called net sales, net sales, net sales, sales net, and net sales amount. All logically similar, all discoverable through search, none consistently reusable. And because people can't find the right measure, they create a new one. That is not a productivity gain. That is semantic inflation. The fourth failure mode is optimization drift, faster DAX that changes meaning. Agents will refactor for performance because performance is measurable, meaning is not. So they replace iterators, they rewrite, calculate logic, they remove filters they think are redundant, they move logic into variables. They introduce keep filters or remove it, they swap all for all selected because it fixes a visual. The number still returns, the query plan improves, everyone claps. But the contract changed. This is how optimization turns into a governance incident 6 months later when finance asks why the monthly margin trend doesn't match the ledger, and the only answer you have is, we optimized it. The fifth failure mode is silent dependency changes. DAX measures are a graph, measures, reference measures. You change one definition, and you didn't just change one KPI. You changed every downstream KPI that depends on it. Agents don't see that graph the way an accountable owner does. They see a task, make this measure. And if you give them tool access through MCP, they can execute that task by modifying multiple measures until the model validates. Validation is not correctness. It is syntax and dependency integrity. So the agent makes a change that technically works and it passes. But your report intent is now broken without errors. The totals moved. The exception logic changed. A calculation group now applies differently. The board pack looks plausible. It is not trustworthy. And here's the part most teams miss. Measures are the easiest place to hide drift because they look like code. Code feels reviewable, but most organizations don't review semantics. They review syntax. They review whether it compiles. They review whether the report still loads. That is not governance. That is hope with a pull request. So if you want one mental model to carry forward, it's this. Every agent-generated measure is a fork of meaning unless you force it to be a reuse of meaning. Next, drift doesn't stay in measures. Once the measure results look off, agents start fixing the model, and relationships are the first lever they pull. Relationship drift, the star schema. You head becomes the graph you fear. Relationships are where close enough turns into structural damage. A measure can drift, and you can still contain it. You can replace it, certify one version, deprecate the rest. Relationships don't work like that. A relationship change rewires filter propagation across the model. It changes what counts as included, even if every measure definition stays untouched. And because visuals still render, most teams won't notice until they're arguing about totals. This is why agents are dangerous in relationship space. When an agent sees numbers that don't match, it doesn't have business intent to reconcile. It has a tool belt, so it tries to make the model behave like the output it expects. And the easiest knob to turn is relationships. The first pattern is the helpful relationship addition. You have a fact table and 2 dimensions, and there's a snowflake table or a bridge that wasn't modeled because the owner made a deliberate choice. Keep the star clean, control ambiguity, force explicit logic in measures. The agent doesn't see deliberate choice, it sees a missing connection, so it adds one. It will pick the most plausible key name match. Custom ID to custom ID, product key to product key, date to date. It will do it fast, it will do it confidently. And it will often be wrong in the only way that matters. It changes the semantics of filter propagation. Now the model answers questions through an implicit join path you didn't authorize. Next comes bidirectional filtering creep. Humans already do this under pressure. Just make the slicer work. Agents do it as a default remediation step. They detect that a dimension filter doesn't reach a table the visual uses, therefore they flip cross-filter direction or set it to both. It feels like a fix. It is not. Bidirectional filtering converts a clean star into a graph. A graph can still be queried, but it's no longer predictable. Filters can travel in loops, and the answer can depend on evaluation order, ambiguous paths, and which relationships the engine chooses to activate. That's not deterministic semantics. That's conditional chaos. The worst part is that this doesn't crash anything. It produces numbers. It even produces the numbers people expect in the specific report the agent was fixing. But it quietly breaks every other report that assumed single direction flow because the same slicer now behaves differently across context. Then there's the many-to-many shortcut. When an agent can't reconcile granularity, it reaches for a bridge table or uses a many-to-many relationship because it often works in demos. And in small models, sometimes it does. But you don't get correctness for free. You get ambiguity with a friendly UI. Many-to-many relationships force you to be explicit about grain, about distinct counts, about duplication, about which side should filter which. An agent does not carry that discipline. It will implement the relationship so the visual returns a result. That result can be numerically consistent and still conceptually wrong because it double counts or undercounts depending on slicer combinations. Next is role-playing dimensions, especially dates. This is where organizations bleed out slowly. Most enterprise models have multiple dates: order date, ship date, invoice date, posting date. The star schema you had relied on explicit choices: a marked date table, inactive relationships, user relationship in measures, control time intelligence. It's not elegant, but it's intentional. An agent sees multiple date columns and sees a problem. So it activates relationships, or it rewrites measures to use whichever date happens to produce the output it expects. Or it creates a second date table because it's seen that pattern before. All of those are possible. None of them are guaranteed to match your business definition of this month. Now, you're not drifting one KPI, you're drifting time itself. And once relationships drift, the model becomes unreviewable by casual inspection. A star schema is legible. You can point to it in a design review and explain it. A graph is not. A graph requires you to reason about propagation paths, ambiguity resolution, and the side effects of convenience settings that were added one at a time. That is why relationship drift is an enterprise multiplier, because the moment the schema becomes a graph, every new measure is now evaluated against a moving target. The engine still returns results, but your ability to explain those results collapses. And when an auditor or a regulator asks why a number changed quarter over quarter, the agent adjusted relationships to fix a report is not an explanation, it's an admission. Now add fabric automation on top, PBIP, PBIR, and agents editing report artifacts as files, and you get drift in the presentation layer too. PBIR, PBIP, and the illusion of report as code governance. PBIR and PBIP get sold as report as code, and teams hear what they want to hear. Finally, governance. Git pull requests, CI/CD, the same discipline they already use for everything else. Here's the problem. A Power BI report is not code. It is configuration state serialized into a pile of files with multiple overlapping places to define the same outcome. And when you give agents permission to edit that state, you don't get software engineering. You get faster entropy with nicer diffs. PBIR decomposes a report into folders and JSON, pages, visuals, bookmarks, filters, themes, interactions, layout metadata. That decomposition is useful. It makes changes trackable. It makes automation possible. It also makes what changed harder to understand. Because in PBIR, the same visual outcome can be produced by settings in multiple layers: the report theme, the page background, the visual JSON, conditional formatting rules, and sometimes even model metadata driving formatting defaults. You can change a color and touch 3 different files. You can change a slicer interaction and touch a single line that looks irrelevant. You can fix a chart by altering a hidden filter container you didn't know existed. So when people say it's in Git, what they usually mean is we can see that something changed. They still cannot see whether the meaning changed. A code diff tells you that JSON keys moved. It doesn't tell you that a report's analytical intent shifted from show trends with optional segmentation to show only the pre-filtered slice that makes the KPI look stable. That distinction matters, because report semantics are not cosmetic. Filters, interactions, bookmarks, and page navigation encode business logic. The report decides what a user can see by default. It decides which comparisons are easy and which are hidden. It decides whether a slicer affects one chart or all of them. Those are semantic decisions just expressed in UI metadata instead of DAX. Now add agents. An agent can open PBIR, search for a pattern, and replicate it across pages. It can standardize formatting, it can align visuals, it can rename titles, it can bulk edit filter panes. And if you give it tool access, it can do all of that at scale across hundreds of reports without ever seeing the business conversation that justified the original design. So you end up with a specific failure mode. Agents replicate layout without replicating analytic intent. The report looks consistent. The story it tells is no longer consistent. This is where report as code becomes a governance mirage. The pipeline can validate syntax. It can validate schema. It can validate that the JSON is well-formed and the artifacts deploy. It cannot validate that the report still answers the right questions. And PBIR makes the blast radius bigger than teams expect. The agent doesn't need to touch the model to change outcomes. It just needs to move a filter from page scope to visual scope, or disable an interaction, or apply a bookmark as the default view, or leave behind a hidden slicer that pre-filters the page while looking like a neutral report. Everything still renders. The numbers still look plausible. Your audience trusts it anyway. Now tie this back to the research reality you already have in the community. PBIR is new, still evolving, and there aren't millions of mature examples for agents to learn from. In that agentic report development discussion, the point wasn't that PBIR is bad, it was that the format is complex, interactions are non-obvious, and without scaffolding, agents don't reliably know where a decision is encoded, so they guess, and when they guess, they change state. Even when you do provide scaffolding, instructions files, examples, templates, the agent is still operating on a representation problem. It sees JSON, it doesn't see the stakeholder conversation, it doesn't see why the CFO demanded a specific exception view, it doesn't see the historical baggage behind a temporary bookmark that became permanent. It sees patterns, therefore it produces pattern-shaped edits. This is why the phrase small change stops meaning anything in PBIR. A one-line JSON change can rewrite the interactive behavior of an entire page. A bulk rename can break user trust because familiar fields disappear. A copied visual can carry hidden filters into a new context and quietly bias the result. So yes, PBIR and PBIP enable disciplined workflows, but only if you treat them as what they are, a massive multi-file state surface that requires semantic review, not just diff review. And once you attach agents to that surface, especially through tool protocols and APIs, you've turned suggestions into state changes. Next, that control plane gets even more dangerous when agents operate through MCP and automation tooling, because now the platform isn't just editable, it's programmable. MCP and tooling. The control plane got faster, not safer. MCP is where the story stops being theoretical, because once an agent has tools, it's no longer helping you write DAX. It's operating the control plane, and the control plane is where the platform's state changes. Measures, metadata, translations, relationships, formatting, descriptions, even bulk refactors that touch hundreds of objects in one run. That distinction matters. In a traditional workflow, an LLM suggests, you copy, you paste, you run it. That friction is an implicit safety gate. Annoying but real. With MCP, that friction disappears. The agent can read the model, decide what to do next, and execute the change directly through a tool call. Faster, yes. Safer, no. MCP servers are accelerators. They're designed to make repetitive operations cheap. Bulk rename measures, add descriptions, standardize formatting strings, generate SVG measures, refactor code into UDFs, apply translations, tweak relationships, create tables, run traces, run validation queries. The exact things teams hate doing manually, so the agent starts doing them. The uncomfortable truth is that most organizations do not have mature semantics for what done means in those tasks. They have technical acceptance criteria. Does it deploy? Does it refresh? Does the report render? Did the error go away? Agents optimize for that. If you give an agent the ability to run tool calls, its success metric becomes no errors, not correct definition, not approved meaning, not aligned to finance policy, no errors. And you can watch this failure mode in real demos. An agent tries to create something, hits an error, tries again, hits a different error, tries a different approach, and eventually gets a green check. That looks like problem solving. It is. But it's problem solving against validation constraints, not business truth constraints. That means you get a new category of drift. Iterative state mutation. The agent doesn't make a careful change. It makes a sequence of changes until the system stops complaining. And each attempt can leave residue. A partially created object, a renamed artifact, a new measure that compiles but isn't used, a relationship that fixed one visual and broke another. Even when it rolls back, you're trusting that rollback actually restored the previous semantic state. Trusting the tool is not governance, and there's another more subtle failure mode when agents lie about what they changed, not maliciously, mechanically. They summarize what they intended to do, what they think they did, or what would have been reasonable to do. If you don't validate against the actual model state, you'll believe the narrative. You can see this in MCP workflows where the agent says it created functions or updated measures or applied a refactor, and then you open the model and find errors, missing objects, or changes that didn't actually occur. The tool calls might have failed, the model might have rejected part of the update, or the agent might have switched strategies mid-run and lost track of the final state. The system is deterministic, the agent's narration is not. So, architecturally, you have to treat MCP as a privilege boundary. It is not Copilot with plugins. It is a write-capable automation surface for your semantic layer. The same way Fabric REST APIs and service principles gave you power at scale, MCP gives you power at scale with natural language as the interface. That makes it more accessible. It also makes it easier to misuse because now just make it work becomes a bulk operation. And when bulk operations touch semantics, drift stops being local. It becomes systemic. This is also where identity starts to matter. If you run MCP through your own user context, the agent has whatever you have. If you run it through a service principle, it has whatever you granted that identity. Either way, tool access turns into authority. The agent becomes an actor in your governance model, whether you admit it or not. And once an agent is an actor, the real question is no longer did it work. The real question is who authorized the semantic change that it just made? Because that's the thing you cannot reconstruct later if you didn't capture it up front. Next, this becomes an audit problem, not a modeling problem. After the fact, you can't prove intent. Auditability collapse. You can't prove intent after the fact. Auditability is where most agentic BI conversations die in the real world. Not because auditors hate AI. Auditors don't care what tool you used. They care that you can answer 4 questions without improvising. Who changed it? When did they change it? Why did they change it? And what policy or business rule authorized the change? In Power BI and Fabric, that applies to everything that affects meaning: measures, relationships, calculation groups, Power Query steps, role definitions, certified datasets, report filters, default bookmarks. If any of those changed, you need to show intent. Now here's the architectural problem. An agent can generate change history, but it cannot generate intent history unless you force intent into the workflow before the change happens, because intent is not a log line. Intent is a decision. Most teams think we have logs means we have governance. They point to activity logs, Git commits, Fabric item history, MCP tool call traces, Copilot chat transcripts. None of those answer the auditor's question because none of those artifacts explain the business rule that was approved. A tool call log tells you that the agent edited measure X at 14:03. It does not tell you that finance approved changing net revenue to exclude internal transfers starting in Q3 and that the change aligned to policy FinRev 04. That distinction matters. Tool telemetry is not governance evidence, it is exhaust. And when agents are involved, the exhaust gets noisier while the evidence gets thinner. You can end up with hundreds of micro changes, many of them iterative attempts, and the only stable thing you can say is that the model validates. That is not a control, that is an absence of alarms. The collapse happens in 3 steps. First, the agent makes a semantic change as part of fixing something else. A measure gets refactored for performance, therefore a filter gets moved, therefore a relationship gets adjusted, therefore a downstream KPI shifts. It's one task in the agent's mind. It's 4 separate control failures in an audit review. Second, the human reviewer cannot reliably interpret the change surface. PBIR diffs are structural noise. Model diffs show metadata churn. A PR can include dozens of JSON and model edits with no way to see the semantic delta unless you translate it into business language. Most teams don't do that translation. They merge because it looks reasonable. Third, when the question comes later, why did this KPI change last quarter? You have no artifact that ties the delta to an approved intent. You have a commit, you have a deployment, you have a chat session where someone asked for optimize revenue measure. That is not intent, that is a request for velocity. This is where the missing artifact becomes obvious, the semantic decision record. Call it an SDR if you want, call it a decision log, call it a data contract. The name doesn't matter, the function does. A semantic decision record is a small explicit statement that says this is the business concept, this is the approved definition, these are the constraints, this is the owner, and this is the effective date. And then it links to the exact change set that implemented it. Without that, you cannot prove that the system changed for a legitimate reason. You can only prove that it changed. And it changed is not acceptable in regulated environments, in financial reporting, in healthcare metrics, in operational KPIs that drive compensation, pricing, staffing, or risk. Even if you're not regulated, you still get the same failure in executive trust. Once leaders see 2 different numbers for the same question, they stop trusting the platform and start building shadow spreadsheets. Drift becomes compliance debt. Not because a regulator shows up tomorrow, but because every unowned definition becomes a future incident. Every agent-fixed measure becomes a future reconciliation. Every undocumented change becomes a future argument where nobody can win because nobody can prove what was intended. So the reframing is simple. If you can't reconstruct intent, you don't have governance. You have telemetry. And telemetry is what you look at after the system already did the thing you needed to prevent. Next, the same lack of intent shows up in a different form. Security and access assumptions erode because agents expand pathways faster than your permission model can keep up. Permission drift. Agents expand access paths without you noticing. Permission drift is the quiet twin of semantic drift. You can argue about definitions in a meeting. You can't argue with an access path you didn't know existed. Agents need reach. To help, they require access to semantic models, lakehouses, warehouses, workspaces, gateways, and APIs. And the moment an organization treats the agent like a productivity feature instead of an identity, it starts handing out permissions the same way it hands out exception clauses, temporarily, broadly, and with no retirement plan. The first mistake is overscoping by convenience. Someone wants the agent to bulk update measures across multiple models, therefore they grant contributor on the workspace. Someone wants it to read data to validate outputs, therefore they grant access to the lakehouse. Someone wants it to deploy PBIR changes, therefore they grant write access to the repo and the pipeline identity. It works. The task completes. Everyone moves on. That is how an agent becomes a permanent admin-shaped hole in your control plane. Because in Fabric, privileges compose. Workspace roles, item permissions, data permissions, and external tool permissions all stack into an effective capability set. If you hand an agent broad workspace permissions, you didn't just let it edit a measure. You let it create new items, modify settings, share artifacts, and potentially expose data through downstream connections you never reviewed. And when agents operate via tools, MCP servers, REST APIs, CLI tooling, the permission boundary is no longer the Power BI desktop UI. It is whatever that identity can do in the platform. So the access model has to be treated like code. Small grants, explicit intent, and expiration. Next is service principals and managed identities. They're often presented as safer because they aren't human. In reality, they're safer only if you manage them like production infrastructure. Most teams don't. They create an app registration, granted broad API permissions, add it to workspace admin, and call it automation. Now the agent has a durable identity that never gets tired, never forgets, and never stops at 5 p.m. That's not a security win. That's a velocity multiplier for mistakes. And it gets worse when the agent starts needing cross-domain access. One model pulls from HR data, another pulls from finance, the third pulls from operations. The agent becomes the glue because it can see everything and help everywhere. That's exactly how data boundaries collapse in large tenants. Not through malice, but through convenience. There's also a newer risk surface, context leakage. Agents don't just act, they ingest. They pull metadata, sample data, measure expressions, error messages, even snippets of query output to reason about what to do next. If that context goes into prompts, chat logs, or third-party tool telemetry, you now have sensitive information replicated outside the governed data plane. Even if the raw data never left the tenant, the meaning might have. Column names, customer identifiers in error text, fragments of PII in debug output, relationships that reveal business structure. That is still leakage. It's just more subtle than a file export. And you can't rely on the agent respects permissions as a security story. Of course it respects permissions. It operates as the identity you gave it. So if you gave it permission to bypass RLS assumptions, by querying a model as an owner, by using an API endpoint that returns more than a report viewer would see, by operating in a workspace where the semantic model is shared too broadly, then your security model didn't get bypassed. It got redesigned by omission. This is the architectural law. Every new integration pathway is a new access path. Agents create pathways. Tools create pathways. Just for this one automation creates pathways. Over time, those pathways accumulate and the tenant stops being a set of controlled workspaces and becomes an authorization graph nobody can accurately reason about. That is permission drift. And it lands you in the same place as semantic drift. You can't prove what should have been allowed because you never encoded intent into the system. So the fix is not ban agents. The fix is to enforce design gates so that autonomy can't expand faster than governance. Next, that means a governance model that treats agent output as untrusted until it passes 4 explicit gates. The governance model, 4 gates that stop drift without killing velocity. So what actually stops drift isn't better prompting. It isn't more careful agents. It isn't asking the same model 3 times and picking the answer that feels right. Drift stops when the platform refuses to accept semantic change without intent. That means you need gates, not guidelines, not training. Gates. Mechanisms that constrain what can happen, where it can happen, and what proof must exist before it becomes shared truth. Here's the governance model that works with agents instead of pretending agents will behave. 4 gates. And yes, it adds friction. That's the point. The friction is targeted at the only place that matters, semantic authority. Gate 1 is intent mapping. Before an agent generates anything, you force the human to state what correct means. Not in prose, in constraints. Scope, allowed operations, definitions, and exclusions. If you cannot write the intent down, you are not ready to automate it, because the agent will otherwise invent the missing constraints, and it will invent them differently every time. Intent mapping turns build me a KPI into build this KPI under these rules, using these tables aligned to this calendar, with these exclusions, and with this owner. It creates a deterministic contract the agent has to follow. Gate 2 is change containment. Agents don't get to operate on production state, ever. You don't let an agent just update the model. You let it work in a sandbox, a branch, a separate workspace, a cloned semantic model, a PBIP project copy. You bound its blast radius. You make rollbacks boring, you make failure cheap. Containment is what prevents iterative tool calling from becoming iterative corruption. Because agents don't make one change, they make sequences. So you isolate the sequence from anything people trust. Gate 3 is review and verification. This is where most organizations lie to themselves. They think code review equals semantic review. It doesn't. Verification means you test meaning, not syntax. You validate outputs against known scenarios. You test time intelligence against your fiscal boundaries. You test filters that historically break. You compare before and after. You detect new relationships, cross-filter changes, many-to-many additions, calculation group changes. And you do it in a way that produces evidence. That evidence is what makes governance real. Without it, you're just approving looks fine changes at scale. Gate 4 is release and attestation. Nothing becomes certified, promoted, or shared until an accountable owner signs off that the semantic contract is still true, and that sign-off needs to be attached to the change set. Not a meeting note, not a chat thread, a durable artifact. Who approved it? What definition changed? Why it changed? What policy governs it? And what version is now authoritative? Attestation is what makes auditability survive. Now notice what this model does. It doesn't treat the agent as a developer. It treats the agent as an untrusted automation engine operating inside a controlled pipeline, the same way you treat infrastructure as code. Fast execution, strict gates, and a clear chain of approval. And this maps cleanly onto Fabric's lifecycle if you stop trying to make Fabric self-service mean uncontrolled. Intent mapping aligns to your design stage. The semantic decision record, the data product definition, the contract for what this model is allowed to mean. Containment aligns to development environments, separate workspaces, deployment pipelines, PBIP projects in repos, isolated identities. The agent works where mistakes are survivable. Verification aligns to CI, automated checks where possible, and mandatory semantic review where automation cannot prove meaning, because it refreshed is not a test. Release and attestation aligns to promotion, the point where you mark a data set as endorsed, certified, or production ready, and you can defend that claim later. This is also how you keep velocity. Agents remain valuable where they should be valuable. Generating scaffolding, doing repetitive edits, documenting measures, applying formatting rules, translating metadata, creating drafts of logic that humans can verify. They stop being valuable where they are most dangerous, silently redefining business meaning through unchecked autonomy. So the 4 gates aren't a bureaucracy, they're an architecture. They make autonomy safe by making intent explicit, blast radius small, verification mandatory, and releases traceable. And if you're wondering where this fails most often, it's gate 1. Most teams can build pipelines. Most teams can do reviews. Most teams can deploy. What they cannot do is write down semantic intent in a form that can be enforced. That's where drift begins. So that's where the fix begins. Gate 1, intent mapping as a deterministic contract. Gate 1 is intent mapping, and it's where organizations either become capable of safe autonomy or they get drift as a service, because intent is the only thing agents don't have. They have patterns, they have tools, they have the ability to mutate state until validation passes, but they don't have the business decision that makes one definition acceptable and another definition a governance incident. So intent mapping isn't write better prompts. It is a deterministic contract that the agent is not allowed to improvise around. Start with the simplest rule. Define the allowed operations, not what you hope the agent will do. What it is permitted to do. For example, create measures only, no relationships, no Power Query rewrites, no calculation group edits, no table additions, no renames outside a defined namespace, no touching certified assets. That scope has to be brutally narrow because a narrow scope creates predictable outcomes. If you can't state the scope in one sentence, you're not delegating a task. You're delegating ambiguity. Next, define the semantic constraints. This is the part most teams skip because it feels like bureaucracy. It is not. It is the only way to stop the agent from inventing your business rules. Semantic constraints are things like which tables are authoritative, which columns are approved inputs, and which existing measures must be reused instead of recreated. It's also where you encode calendar law. Which date table is the only valid date table, which fiscal year definition applies, and which date columns are allowed for time intelligence. In other words, you're telling the agent what time is, what customer is, what sale is, and what exclude means in your organization. Because if you don't, it will pick defaults, and defaults are never your policy. Then enforce naming conventions as rules, not style. Most naming guidance is optional, therefore it erodes. Agents accelerate erosion by generating names faster than people can normalize them. So the contract must include a naming grammar, prefixes, suffixes, display folders, and prohibited synonyms. Not because it makes the model pretty, because naming is how users discover and reuse definitions. If the names drift, the semantics fork. A deterministic contract also includes reuse boundaries. If a measure exists in the certified model, reference it. Do not create a variant. That single rule collapses an entire drift vector because it forces convergence instead of duplication. Now add the ask 3 questions first pattern. This matters because agents will start work immediately unless you force clarification. The 3 questions are not philosophical, they're mechanical. First, what is the business definition in plain language, including inclusions and exclusions? Second, what is the grain and the time logic? Daily, monthly, fiscal, calendar, posted date, invoice date, last refresh date. Third, what is the expected validation example? A known number, a known slice, a scenario where the result can be checked. Those 3 questions turn the task into something testable, which means Gate 3 can later verify it. Without them, you will approve looks right outputs, and drift will survive review. And yes, the community has already stumbled into this truth. In the agentic report development discussions around PBIR and context engineering, the most valuable outcome wasn't faster visuals. It was being forced to document what you wanted before the tool could do anything useful. That is not a productivity tax. That is the missing discipline most BI teams never institutionalized. Now make the output of Gate 1 tangible. The result is an artifact, a short intent spec, not a 5-page requirements document. A compact contract that includes scope, constraints, required reuse, naming rules, and validation cases. 1 page, 2 pages maximum, stored with the work item, linked to the change set. Reusable as future context. This is where you stop treating models as artifacts and start treating them as products, because a product has contracts. A product has owners. A product has defined semantics that don't change because someone asked an agent to make it faster. Finally, intent mapping has to be enforceable. If it lives only in a Word document, it will be ignored at scale. It has to live where the agent runs. instruction files, policy as code checks, tool allow lists, and pre-flight validations that block prohibited operations. The moment the agent can violate the contract, you are back to probabilistic semantics. So gate 1 is not documentation, it is authorization for meaning. And once meaning is authorized, the next problem is blast radius, because even correct changes become dangerous when they're applied directly to shared state. That's why gate 2 is containment. Gate 2, containment. Sandboxes, branches, and scoped identities. Gate 2 is containment, because even when your intent is perfect, execution still isn't. Agents don't apply one surgical change. They iterate, they try something, hit a validation error, try a different approach, and keep going until the platform stops complaining. That's not reckless. That's literally how tool-using agents work. Action, feedback, action, feedback. So you don't contain the agent because it's evil. You contain it because iteration creates blast radius. The rule is simple. Agent output is never production state. It is a proposal. That means you treat every agent run like a branch, not a commit, not a hotfix, a branch. Something you can throw away without a post-mortem. In Fabric terms, containment starts with where the agent is allowed to operate. You don't point an agent at the certified semantic model and say optimize measures. You point it at a copy, a development workspace, a sandbox semantic model, or a PBIP project checked out in a repo. You isolate the run from the assets people already trust. Because when an agent is wrong, it will be wrong quickly, and it will be wrong everywhere it can reach. This is where environment design becomes governance, not tooling trivia. A separate workspace for agent runs isn't process overhead. It's the difference between a contained failure and a tenant-wide semantic incident. Then you wire that containment into your lifecycle. If you already use deployment pipelines, treat the agent workspace as the same class of environment as dev. Let the agent mutate dev artifacts. Promote through the pipeline only after gate 3 verification. Never let the agent bypass the promotion boundary. If you are using PBIP and PBIR, containment becomes even more literal. The PBIP project is the boundary. The repo is the boundary. The agent can edit files in a branch, generate a PR, and stop. That's the correct shape. Changes are visible, reviewable, and reversible. What you don't allow is direct edits in production workspaces because it's faster. That's how you turn an agent into a release engineer with no accountability. Containment also means scoped identities. This is where most teams sabotage themselves. They run agents under a human user with broad permissions because it's easy, or they create a service principal with tenant-wide rights because automation needs access. That is not automation, that is unmanaged authority. The agent's identity must be minimum viable permission, not minimum viable friction. If the task is create measure descriptions, the agent doesn't need to edit relationships. If the task is bulk rename measures, the agent doesn't need access to the lakehouse. If the task is generate a report page in PBIR, the agent doesn't need workspace admin. So you scope the identity to the exact surface area you want the agent to touch. And you scope it in time too. Standing access is lazy design. Time-bound access is containment. The clean model is the agent gets a scoped identity for a defined window on a defined workspace with a defined allow list of tool operations. When the run ends, the permissions end. If you can't enforce that technically, you enforce it operationally with separate identities and separate environments. Now add deterministic backups. This is the part nobody wants to do until they need it. Before an agent run, you take a restore point. For PBIP, that's trivial. Branch, tag, commit. For service artifacts, you need an equivalent. Export the model metadata, checkpoint the workspace, or at least ensure the previous promoted version is recoverable in the pipeline. Because rollback is not a nice to have with agents, it is a design requirement. You are not protecting yourself from a single bad change. You are protecting yourself from a sequence of changes that passed validation but corrupted meaning. Containment also reduces the temptation to let the agent fix it live. Once teams see a demo where MCP can update measures in real time, they start treating production as an interactive sandbox. That's entertaining. It's also how you lose the only thing governance is supposed to preserve, a stable truth layer. So gate 2 is how you keep experimentation without sacrificing trust. Agents can run fast. They can try 10 variations. They can refactor aggressively. They can generate drafts and alternatives. In containment, that's fine. That's value. Outside containment, that's drift with better UX. And once you've contained the blast radius, you still haven't solved the real problem, because a contained wrong change is still a wrong change. Containment prevents disasters. Verification prevents subtle corruption. That's gate 3. Gate 3, verification, works is not a test. Gate 3 is verification, because it worked is not a test. It's a symptom. The platform didn't throw an exception. That's all. Power BI and Fabric will happily return a number for almost anything. DAX will happily evaluate under the current filter context. Relationships will happily propagate filters down the best available path. PBIR will happily render a report that encodes a biased default view. None of that proves the output matches the business definition you think you have. Verification is where you force the model to prove meaning, not just compile. The first shift is semantic unit testing, not performance testing, not does the visual load, Semantic tests are small, explicit scenarios where the expected behavior is known and stable. For example, net revenue for customer X in fiscal month Y must equal the ledger extract total for that cohort within a defined tolerance and with explicit inclusion and exclusion rules. Or active customers must not count internal accounts, must not count test tenants, and must use the posting date, not the order date. The point is not that every KPI needs 1,000 tests. The point is that every KPI needs at least one scenario that proves its contract. Without that, you are approving vibes. Now, teams hear tests and think they need a full engineering platform before they can start. They don't. They need a habit. A small set of canonical slices and expected outputs that get checked before promotion. In Fabric terms, this can be a set of DAX queries that return known values or a comparison query that validates deltas against the baseline. It can be lightweight, it just cannot be optional. Next is separating performance from correctness. Agents love optimizing because optimization produces measurable feedback. Fewer storage engine scans, shorter query durations, fewer formula engine hits. It looks scientific, it looks disciplined. But performance improvements are worthless if the definition drifted. So the rule is prove correctness first, then optimize. If an agent proposes a refactor, Gate 3 must validate that the refactor produces identical results across the test scenarios, not roughly similar, identical where it matters, and within policy-defined tolerance where it doesn't. If you can't prove equivalence, you didn't optimize. You changed the KPI. That distinction matters when executives build decisions on that KPI. Then there's diff interpretation. PBIR and model metadata diffs are too low level for most reviewers. You can see change, but you can't see intent. So Gate 3 requires translation. Turn the raw diffs into a human language change summary that describes semantic impact, not updated visual JSON. That's meaningless. It needs to say, moved filter status equals posted from visual scope to page scope, or changed measure net revenue to exclude returns table, or added bidirectional filtering on customer sales relationship. Those are semantic changes. Those are reviewable. If you can't translate a diff into meaning, you can't approve it. Gate 3 also needs explicit reject criteria. This is where you stop pretending every change is negotiable. Some changes are structural drift generators, and you reject them by default unless an owner explicitly authorizes them in Gate 1. Reject criteria should be boring and absolute. New relationships, changes in cross-filter direction, new many-to-many relationships, new inactive-to-active relationship flips, new date tables, calculation group edits, and time intelligence that references non-approved date columns. If the agent introduces any of that, the change fails verification unless the intent contract explicitly allowed it, because those changes rewrite the model's behavior in ways most teams cannot reason about under pressure. And then there's the human-in-the-loop rule. This isn't best practice, yet it is design law. Semantic changes require a human owner to accept accountability, not to rubber stamp a PR, but to accept that a business definition changed, and that the organization will live with the consequences. The agent can generate, the agent can refactor, the agent can even propose tests, but the human approves meaning. That is the point where governance becomes real. Someone with domain authority signs the contract, not just the code. Finally, verification has to be fast enough that teams don't bypass it. That's why you don't build a massive test harness first. You build a thin one that catches the common failure modes, time logic errors, filter propagation changes, duplicate definitions, and hidden defaults in reports. If you catch those, you catch most drift early, and if you don't catch them, you will catch them later in production in front of stakeholders with no ability to prove what changed. Gate 3 prevents subtle corruption, but it still doesn't make change safe by itself, because even correct verified change can become ungoverned truth if you promote it without provenance. That's why Gate 4 exists, release and attestation, where traceability becomes part of the product. Gate 4, release and attestation, provenance becomes the product. Gate 4 is where most organizations get uncomfortable because it forces a confession. The semantic model isn't just a technical artifact. It's a decision surface, and decisions require owners. Release and attestation is the point where you stop treating deployed as true. You only promote what you can defend later, under questioning without hand-waving. That means provenance becomes part of what you ship. In practice, Gate 4 starts with required metadata. Every promoted semantic change needs a minimal provenance bundle. Who approved it, what changed, why it changed, what policy or definition it aligns to, and what version is now authoritative. If you can't answer those 5 things from a durable artifact, the release doesn't happen. This is where teams try to substitute process theater. They'll say, it's in Git, or the agent log shows the tool calls, or we have the chat transcript. None of that is attestation. Those are implementation traces. Attestation is an explicit statement of responsibility. So the release pipeline needs a hard rule. Semantic changes require sign-off by a named owner with domain authority. Not the developer who merged the PR, not the platform admin, the person who owns the meaning of the KPI. That's not bureaucracy. That's the only mechanism that prevents the agent did it from becoming your organization's default excuse. Next, align attestation to endorsement. Fabric already has the concept of promoted and certified datasets. Treat those badges as governance boundaries, not decoration. Agents should not operate against certified datasets directly. They should operate on drafts and candidates, and certification should be the final act of Gate 4. That creates a clean operating model. Uncertified assets can be experimental and fast. Certified assets are contract-bound and slow to change. If your tenant doesn't enforce that separation, you've built a semantic commons with no law. Purview and lineage also matter here, but not as a checkbox. Lineage is useful only if it connects to intent. If the lineage graph says, this model feeds this report, that's fine. What you actually need is, this definition was approved for this purpose, and you need it discoverable. So Gate 4 requires that promoted artifacts surface in the governance inventory with ownership metadata, sensitivity labels where appropriate, and a traceable link to the semantic decision record. If you can't find the owner in 2 clicks, you don't have a governed data product. You have a shared file with better marketing. Now, the other half of Gate 4 is operational reality. Roll forward and roll back. Everyone loves to talk about rollback like it's a comfort blanket. But with semantic drift, rollback is harder than it sounds. Reports get rebuilt around the new truth. Stakeholders adapt. A broken KPI becomes the new baseline in someone's forecast. So you need both policies, when you roll back and when you roll forward with a fix. That means release needs 2 things every time, a recovery plan and an expiry plan. Recovery plan. If this change is wrong, how do you restore the previous certified version quickly? Expiry plan. If this change was temporary, what forces you to remove it later instead of letting it become permanent drift? This is why exception clauses are entropy generators. Gate 4 is where you either retire them or you formalize them into policy. You do not leave them floating in the model. And now the KPI nobody tracks, but everyone should. Drift rate. Not how many commits, not how many deployments. Drift rate is semantic churn, how often the definitions that matter change, and how often they change without a corresponding business decision record. If drift rate goes up, your governance is failing, even if your CI/CD looks pristine, because the platform can be perfectly automated and still semantically unstable. In fact, automation accelerates instability when you don't control meaning. So Gate 4 is the final architectural posture. Provenance is the product. If you can't prove it, you can't ship it. And if you ship it without proof, you've moved from analytics into storytelling with numbers. Next, there's an uncomfortable question that always follows once the gates exist. When should you use agents at all? And when should you keep them away from the semantic layer entirely? Practical operating model. Where agents belong and where they don't. So, where do agents belong once the novelty wears off and you're trying to keep a tenant coherent? They belong where the work is repetitive, the semantics are stable, and the blast radius is containable. In other words, agents are excellent mechanics. They are terrible legislators. Safe uses are the boring ones. Documentation, descriptions, metadata hygiene, translations, foldering, formatting strings, measure annotations, and building out standardized scaffolding from a template you already trust. If you already have a certified measure library, an agent can help you apply it consistently, rename to match taxonomy, move measures into the right display folders, add consistent descriptions, and generate a change summary that a human can actually review. Agents are also useful for bulk refactors that are syntactic, not semantic, replacing a table name after a rename, updating formatting rules, applying a known pattern across many measures, or generating visual layout changes when the intent is explicitly defined and verified. This is where PBIR, PBIP automation pays off. Not designing a story, but enforcing an existing story across reports. Conditional uses exist, but only under gates. Measure scaffolding is a good example. If the organization already owns the definition and the calendar rules, an agent can draft the DAX quickly, propose variants, and even suggest tests. But the agent never decides the definition. It never picks the date column. It never invents exclusions. It drafts. You approve. If you want a simple rule, agents can automate expression, not authority. Now the hard line, where agents don't belong. Agents don't belong in relationship creation, schema redesign, or the definition of business KPIs without an accountable owner driving it. Relationship drift is too destructive and too non-obvious. And schema redesign is not a technical improvement. It is a change in meaning because it changes how filters propagate and what belongs to a result. Agents also don't belong in anything that expands semantic surface area without a retirement plan, new date tables, new many-to-many bridges, new calculation groups, new temporary measures meant to satisfy a single executive question. Those are entropy generators, and agents produce them faster than humans can clean them up. This is also where maturity matters, and it is not negotiable. If a team can't ship a stable semantic model without agents, it will not ship a stable semantic model with agents. It will ship instability faster. Process fidelity has to exist before autonomy. That's the uncomfortable truth behind every glossy agent demo. The demo works because someone already had structure, templates, conventions, and a review process. The agent didn't create that, it consumed it. So the operating model is straightforward. Use agents to accelerate the parts of the lifecycle you already control. Use them to reduce human toil in the areas where your intent is already encoded. Naming, formatting, documentation, replication, refactoring within known boundaries. Do not use agents to replace the only scarce resource in the system, semantic ownership. And if you're thinking, but we need speed, good. Speed is not the problem. Unbounded speed is. The decision rule that holds up in enterprises is simple. Automate repetition, not meaning. If the work is repeatable and the output can be verified deterministically, an agent is a force multiplier. If the work requires a business decision, an agent is just a confident guess with tool access. So yes, agents can belong in your Fabric operating model, but only after you decide what the semantic layer is, a product with contracts, owners, and gates. Because if you don't, the platform will do what it always does. It will drift toward convenience. Control the semantics or the semantics control you. Agents can accelerate delivery, but only governance gates preserve semantic truth when Power BI and Fabric are being changed at machine speed. If you want the next step, watch the deep dive on implementing the 4 gates in Fabric and DevOps, branching, sandbox identities, semantic tests, and MCP tool allow lists. Without turning your tenant into an authorization graph nobody can explain. Subscribe if you want more architecture that survives contact with reality.